So this section covers two main topics. One is kind of what is described as a library of commonly encountered functions. The square root function, a squared function, a line, a cubic, an absolute value, some strange functions, and with some information accompany them. In my judgment, the single most important parts of this section are the parts that deal with identifying increasing and decreasing functions. And then as a corollary to that, using the idea of increasing and decreasing to identify what the textbook calls relative maxima and relative extrema. I won't use those words, or I won't prefer those words. I will use local maximum and local minimum, or local maxima and local minima. So the sheet that you will find on Canvas has 4 questions on the front and 4 on the back. I'm going to do the 4 here, post this on YouTube, and then, or that's the plan. Hopefully upload successfully, and then you can work on those. This will be for Wednesday, I believe. So the first question is this: sketch the graph of a function that is first increasing on the interval, the open interval, -∞ to -3, that is constant on the interval from x equals -3 to x equals 2, and is increasing on the open interval 2, infinity. So there's not one right answer, and I have posted, or I have included 2 in my sketch. So x and y axis, I've made a blue and a pencil graphite gray. So it's increasing. So here's x equals -3. It's increasing, meaning that the graph is rising, going up from left to right on the interval -∞ to -3. It is constant. That is, the y value does not change when x changes from -3 to 2, and then it increases for all x values beyond 2. And so I have 3 segments that are each straight, and here I have kind of a curved representative: increasing, constant, increasing. Sketch graph of a function that is increasing for all x values less than -3. Notice I'm interpreting the interval in that fashion. Decreasing on the open interval -3 to 0, and increasing on the interval 0 to infinity, or increasing for all x values greater than 0. Additionally, does it appear that this function has any local maxima or minima? If yes, for which x values? Right? So we're looking for local maxima and minima. A maximum on a graph looks like a peak, and a minimum looks like a valley. And here we have 2 examples: increasing for all values up to -3, for all x values up to -3. Again, this blue one, the graph is rising from left to right. Decreasing from -3, x equals -3 to x equals 0, so coming back down, and just decreasing, going down, and then increasing on the open interval 0 to +infinity, and then the arrow suggests it continues in this fashion. Here is an example of a straight line version. All the pieces are straight lines. Increasing up to x equals -3, decreasing between x equals -3 and x equals 0, increasing beyond 0. And it looks like it has a local maximum, something shaped like this, at x equals -3, and this, I've only indicated the blue one here. I've tried to color code it. It looks like the maximum, the local maximum, locally, the maximum is -1. It gets all the way up to -1. The y coordinate, the function outputs all the way up to -1 locally, and then locally at there's a minimum value. It's how low does the function get? Well, it gets down to -3 when x is 0, right? So the minimum, the maximum refer to the functional value, the output value, the dependent variable y coordinate. And then here are the straight line versions. Different local maxima and minima behavior, but I haven't specified that just for the blue one. One more, sketch the graph of a function that is decreasing for all x less than -3, that is increasing for x between -3 and 0, open interval -3 to 0, and decreasing on the open interval 0 to infinity. And once again, does this pattern of increasing and decreasing suggest, or does it appear that this function has any local maxima or minima? In as much as this is a pre-calculus class, this is one of the key points to be taken into calculus and then developed deeply and further in calculus, the connection between increasing, decreasing, and maxima and minima local. So let's see, here I've just included one. We will be dealing with examples that tend to be smooth, curvy things, not straight line pieces. This has a local, so it's decreasing on the interval open interval -infinity to -3. You can see it's decreasing, going from left to right. The y values decrease. It's increasing for the open x interval, the open x interval -3 to 0. The y values are increasing on that x interval, and then on the open interval 0 to infinity, positive infinity, the function is decreasing. And if you'll note, I sort of indicated that it's kind of leveling out, it's kind of slowing down, it's not pointing straight down. That's okay, as long as it's continuing to decrease, like a soft landing. We'll use the word asymptote later. It's still decreasing. So it appears that locally 3 is a maximum, that in this locality, the function doesn't get any higher than 3. The y value never exceeds 3, and that's at x equals 0. And it looks like over here, the function has a local minimum at x equals -3, when x is -3. And what is that local minimum value? It is 1. And I have intentionally swapped those around so that we are not thinking about the order in which things are written, but rather the meaning of the particular statements. If it has a local minimum at x equals -3, that means that the horizontal location of this local minimum, of this valley, is x equals -3. There is no indication what the value is. Could be a positive number, could be a negative number, could be 0, could be a very large positive number, could be very negative, could be 0. There's no indication, but it simply says at this location, at this x location, some sort of a valley-like structure occurs, and the minimum value is 0. The functional value down here gets as low as, is 1. Yeah. The next question is a little bit different. It's given a graph, do some analysis on that, identify please note these are x intervals, the open interval on which the graph is either increasing or decreasing, so split that up and state the graph is increasing on this x interval, the graph is decreasing on this x interval, if there are any, right? Find any. And then if there appear to be any local maxima or minima, then just identify the x values. That's all that's required. So we'll have to kind of keep that in mind. But I guess I'll look at the graph and say it is increasing here. So from x -4 over to x equals -1, the graph is increasing. Open interval, even though these are solid dots, increasing and decreasing only refer to open intervals. And then again from 1 to 4, increasing, and then we'll flip back and forth here. So increasing from -4 to -1, and then from 1 to 4. Let's go back. Let's go back. Oh, it's